Hello and welcome to the Section 9.2 application walkthrough. In this section we looked at properties of exponents. I want to start off by looking at a couple of the basic problems and then we'll get into some more complicated ones down below. So in the first problem here, what I've always told you guys is treat numbers like numbers and variables like variables. Okay. Here, I really just have 12 over 3 times d to the fourth over d squared. Okay, 12 over 3 simplifies to 4. And if you remember this is like d to the fourth minus 2. So that's going to be 4d squared. And that'll be my answer. Okay, the next problem is a little bit tougher, but I think that you can manage. I really want to look at these next couple problems because they're pretty good application problems in general. So we're talking about geometric probability, and what that means is that if a point is randomly selected on an object, to find the probability that the point selected lies in the shaded region, use the formula P of shaded region. That means the probability that it lands in that shaded region is the area of the shaded region divided by the area of the entire region. So we're going to be looking at the small rectangle or the smaller shape compared to the bigger shape. Okay, I'm going to do the first one and then let you guys do the last couple. Okay, so I have kind of a guide over here as to what you need to do. First of all, find the area of the shaded region. So that's going to be 3 inches by 3 inches. So area equals 3 times 3, which is 9 inches squared. Okay, the area of the entire region is 8 by 14. Okay, and so you're just going to go 8 times 14. So that's going to be area equals 8 times 14. And that's going to be 112 inches squared. Okay. To find the area of find the probability that it lands in the shaded region, you're going to be looking at 9 inches squared divided by 112 inches squared. So when we do that, I did that wrong, 9 divided by 112, it tells me, I just punched it in on a calculator, and it tells me 0.0803. All right. When we answer probability problems, we usually like them as percents. So I go and move the decimal over twice, and it's 8.03%. So if I just throw a dart at this region, and I know it's going to land in this entire region, 8.03% of the time, it will land in that shaded box there. Okay, so if you notice, the problem that I did really didn't deal with exponents other than the area. Okay, but that wasn't really working with exponents. So these next two problems will, because we have variables in there, and it'll work the same way. Just at the very end, you'll be dealing with some properties of exponents to figure out what you're actually going to get for an answer. Okay, make sure that so this number 4 here, similar to the one that I just did. Like I said, you're just going to have variables in your answer, and that's okay. All right, we can handle that. If you're having trouble writing it as a decimal, as a percent, just leave it in this form here as 1 over the other one. But if you can get rid of those variables, feel free to do so. Okay, and I'm guessing you'll be able to. In this last one, I just want to point out one thing. Okay, this is a circle. It may or may not look like it, but it is. Okay, and one thing that you'll need is the radius. The radius is the distance from the center to the perimeter of the circle. And so since this entire stretch is 4x, this is going to be 1/2 of 4x or 2x. So your radius will be 2x. Okay, so give those a shot. They're pretty good problems. It's a really good thing to know expect maybe a work sample on a problem like this, because they like to do that for a geometry and algebra kind of crossover there. So make sure you're paying attention to that and give it a really good effort. If you have any questions, you can ask me, and I'll be willing to help you, but I do want you to give it a shot first. Other than that, good luck on the Mastery Challenge, and we will see you later.